What's up, guys? Vanzeven here with your next tutorial in Java 2D game engine development. And you may notice the title of this series has changed a little bit, and I commented on the series about this. But what we're going to be doing in this series essentially is I've changed the output of it. It's just going to be developing this game engine. And once we're done that, I will start up 2 or 3 new series, depending on the results of the poll, on the actual type of game we're going to take this engine in. So this engine will turn into a couple different games. Uh, yeah, so just to show you what you guys can do with it. You may also notice that the mic's a little different. I'm not too sure how the quality on this one is. The other one I tried to record with twice before this video, and it wasn't working out, so I got this one, and this one I don't know how it is. So we will see how well it is after I'm done recording. I just recorded one episode of the same thing with this mic, and I was not recording my audio, so I don't actually know how the audio is. So we will find that out. But anyways, so in this one what we're going to be doing is we will be doing some level handling. We may do some tile handling. I'm not sure about the tile handling yet, probably. But yeah. So that's what we're going to do this episode. And next episode we'll do entities and stuff. This episode, the output of it may be a little flawed, just because the entities will take care of stuff like when we move around the screen it might not go far enough and stuff like that, just because we're setting certain variables that we shouldn't be setting to move the screen around, and those input things will get moved into the player class. But yeah, so last episode what we did was we worked out on the font stuff and the text handling here. So you'll see we got our F's done. I think we did that. Might have been 2 episodes ago. You might see that they're a little different than before. That's because I changed up this style sheet a little bit, or the pixel sheet. And here is our text that we wrote on the screen, and we can change that whenever we want. We can now draw text. So that's cool. So what we're going to do is we're just going to remove that for now down here. That's where it is, because we don't need to see that output anymore. Essentially what we're going to be doing is replacing this with the game. So to get started, let's create a new class. We're going to take it out of the graphics package, and we're going to put it in the level package. And we're going to name this level. This is going to be our basic level. I haven't planned out this episode as much as I should have, because I've just been trying to get it to you guys, because I've been pretty busy lately. So that's what's been going on there. But I hope that it still comes across as well put together as the other ones seem to be. So yeah, so we may go back and change some things later. First off, what we're going to need is we're going to need a byte array named tiles. What this is going to be is it's going to be an array of IDs for what tile resides in that specific coordinate. We're also going to need a width, so a public int width, and a public int height, and I think that's it for now. So we'll do public level, int width, and int height, and we're going to say tiles is equal to new byte width times height. What that's going to do is it's going to create a new array of whatever the board size is that we define. And then we're going to say this.width is equal to width. Oops. And this.height, this is going to be weird, equal to height. I'm not actually at my typical recording station right now. I'm at somewhere else. I'm not at a different house or anything. I'm just in a different room. So it's kind of weird typing on this one. And we're going to make a function called generateLevel, just to populate it with some random ambiguous stuff. Let's say public void generate level for, this is essentially going to be that loop, so we could probably just take this loop, because it's going to be that loop right there. We'll go into level, copy and paste it. This contents will all change though, and it won't be 32, it'll be the height here and the width here. And then in here we'll say tiles at x plus y times width, we've done this before, just to get the actual coordinate that we're at, is equal to tile.grass.getID. We'll create that in a second. I will leave this out for now, because we're going to do the render tile function now. So in the render tile function, what we've been seeing currently in the game, actually I'll just comment this line out so we don't have to see it. Actually, that wouldn't matter because we don't have our board. But essentially, okay, let's do it. Why not? There. So if we run this, it'll run. This is the problem that we're going to fix this episode, and this is why it might bug up a little bit. So you'll see we have our board here, and if I go outside of this board with the arrow keys, you'll see that it starts dragging. Now this is because we're not really rendering anything here, and these pixels are kind of not really there. They don't exist, so we're not rendering anything, so it's just kind of dragging whatever output was there last over across. So what we're going to do is we're going to lock it, so that whenever you try to move outside, say, these bounds, if this is the actual bounds of where the board ends, if you try to move outside that, you can't. It'll just stop here, and the player will just move, like, he'll move around in this quadrant instead of going outside of it. So that's essentially what we're going to do. So it may bug out a bit because, again, our input is right here. We're actually directly accessing the screen's offset, which we shouldn't be doing, but it's good for output stuff, for testing. So yeah, so that's what we're going to do. We're going to verify that in the level here. So we're going to say public void render tile, render tiles. It's going to take the screen. It's going to take the X offset. What this X offset and this Y offset are going to be is these are going to be variables in our game class, and it's essentially just going to be the player's position centered on the screen. That's essentially all it's going to be. And then if we need to verify that these coordinates now. So if the X offset is less than 0, we're going to set it to 0. It's equal to 0. If the X offset is greater than the width left shifted 3, because the width of the total board, so the total pixels of the board, so if we're greater than the actual board's width, minus the screen's width, then we're going to set it to that value, whatever that may be. Oops. There. And then we're going to take these two lines and we're going to copy them down one and change all this to information with Y. Speaking about this, while I do this, I've been noticing I've been getting a lot of messages about help on what to do with stuff and why stuff's not working. And for the most part, I'd say for the 95%, it's just stuff like that, where you're not actually copying and changing the information correctly. You'll like leave this as like an X here instead of that Y, and then the whole game it'll just not work because that's an incorrect value. So I've been noticing that. So double check your variables, guys. I'm pleased that you guys are getting it though, because that means that you guys aren't screwing up on anything major. So that's really good. Next, we're just going to set the offset on the screen to this actual offset, because this will kind of be like the camera. That's what this is. This is the camera. And so we're rendering on a camera basis right now. Now we need that for int y is equal to 0, y is less than height, y plus plus, and we'll copy that down one, put that there. Again, change it all to x, so x is equal to 0, x is less than width, x plus plus, format it and save it, Control-Shift-F or Command-Shift-F to format, and Control-Shift-F, Command-Shift-F to save. Next what we're going to do is we're going to say get tile at x and y dot render screen this x bit shifted left 3 and y shifted 3 as well. So we need this get tile function to return a tile. Now this is going to screw up a little bit because we haven't actually, let's make our tile class just to screw things up. We'll put it in the .level.tiles just to get some of the warnings away. Okay, so we have our tile class. So that should go away and it should go to grass. Same with there. We'll create a render function actually as well, because we can do that. And yes, and instead of I and J, we'll put X and Y and remove that. Okay, so go back to level. So get tile. So if the tile is outside the bounds of the screen, or outside the bounds of the board, then we're just going to return a void tile. So if the x is less than 0, or the x is greater than the width, or the y is less than 0, or the y is greater than the height, return tile.void. Otherwise, we want to return tile at tiles. Oops. Tile.tiles. So this is going to be an array. Sorry. This is going to be an array inside tiles containing all the tiles inside of it. And then we're going to have, we need to get it at a byte value. So we'll get it at the x plus y times the width. And that should return it correctly. And this should be tiles, not tile there. There we go. Then we will create this function. It's going to be a constant, because it needs to be a static. It's going to be equal to new tile, tile, and 256, just because that's the maximum amount of tiles that we can possibly have with this actual board. So there's that. So this tile.void will create this constant as well. So tile.void is equal to null. We'll copy this down twice. Grass. Actually, let's do stone. Stone. Grass. Okay. So that should be the level class done. We do need to get this stuff, but don't worry about that yet. So what we need to do here is we're actually going to make this an abstract class. Now, what an abstract class is, essentially, I'm going to break this down really quickly. An abstract class is a class that doesn't actually get instantiated anywhere by itself. This is a class that needs to be instantiated by a subclass somewhere. So essentially we'll have a basic tile that extends tile, and that tile, this is kind of a blueprint. Think of it like a blueprint. That's a good way to describe it. This will give us a generic things that need to be implemented in other classes that we can then instantiate from there. So that's why it needs to be abstract, because we're actually not going to be doing this abstract. We're not going to be doing this render method here at all. The render method will be in all the subclasses, not this class. That's fine. Don't worry about this. So we don't actually need to render it here. This is just saying there will be a render function in all these subclasses, essentially. Anyways, so what we will also need is we will need a couple values inside this tile blueprint as well. We will need a byte, an ID. This is going to be the location in this array of where that tile is located. Protected, boolean, solid. We're not going to use these right now. This is going to be for later. Protected boolean emitter. Emitter is going to be for light, and a solid is going to be for collision detection, so we can't pass through it. Next we're going to say we're going to create our constructor with those three values inside it. We're going to accept an int here because we don't want to be casting every time we make a new tile from somewhere. We just want to send it an int and have it cast it here. Boolean is solid, and boolean is emitter. Okay, and we're going to say this dot id is equal to byte id. And then we're going to say if the tiles at id, so if the tile is not equal to null, so if there's already a tile that has this id, we want to throw an exception because that's not allowed. So we're going to say throw new runtime exception and say duplicate tile ID on, we're going to say ID. That's just a verification thing. If we've done something wrong up here, it should never happen because it's a code-based thing. It's not a user end error. Tiles at ID is equal to this, just to set it. And above that, let's actually say this dot solid is equal to solid. Oops. Why isn't my backspace working? Oh, because apparently I had clicked somewhere. This dot solid is equal to is solid. This dot emitter is equal to is emitter. And then tiles at ID is equal to this. So there's that. Next we're going to need a couple different, since these are protected, what protected means, I didn't go over that, sorry. What protected means is it's not public. Public is anybody can look at this and see what it is. Private is only this class can see what it is. Protected is any subclass of this class can see these values. So if we make a basic tile, which we will, that can see the value of ID, but level won't be able to because level doesn't extend this tile. So that's essentially what that means. So these things that we're doing right now these getters and setters. We're not going to do any setters because we don't need to set any values. We're just going to do getters. What they are is they're here so that other classes can actually see the data inside them. So return solid, and public boolean is emitter. So we just want to create these just so that like our level class can see if this is actually a solid block or if it's an emitter or whatever we're doing. So there's that. I think that's all that's in this class. It should be. Yeah. So let's create our basic tile now. Let's actually create these ones. So we're going to create a new class in this tiles. We're going to call it basic tile. You can call it base tile. There's a bunch of different things that you can say. This is just kind of the lowest level tile possible. It's going to extends tile, so you write extends tile. Now I'll throw a couple of warnings. We need to add a constructor and that render function here. Because it's saying you haven't fit the blueprint yet. You got to fit the blueprint, and then I'll ALK your function. We're just going to remove all this debug output because we don't need to see it. This arrow here as well. Why aren't my line numbers on? This arrow here as well will show that it is actually implementing a function in another class. What we want to do now is this is just a basic tile, so it's not a solid and it's not going to be an emitter. We'll have different classes for those kinds of things. So we're not actually going to have that here. We're just going to send it false, false, false. What we are going to send it though is we're going to send it an x coordinate and a y coordinate and a color, because we want to see those things, and then we'll store those values in here. So essentially what this is going to have is, if we go into our game class again and we look at that function that we removed, this function, this is going to be where the x and y are stored. We're essentially populating these two data right here. That's what we're doing with this. So we're going to have a protected, an int, a tile ID, and protected int tile color. And then we're going to say here this dot tile, tile ID is equal to x plus y, and this dot tile color is equal to tile color. Just to set those up. So now that those are set, we're going to go into the render function, and we're just going to say screen.render x, y, tile ID, tile color. See? So we just populated it right there. So that's all we're doing in there. Now we're almost done. We're going to go back into the level, I think. No, level's all good. Oh, we need to go to the tile. That's what I need to do. And we need to populate these things. So the void tile is, we're going to have this set at 0, so we're going to say new basic tile. It's going to be set at 0. It's going to, hold on, I need to see what data is inside these. Okay, so it's going to be an ID of 0. It's going to be at coordinate 0, 0, because we're actually going to have a physical tile for a void tile. And then the colors, it's just going to be 0, 0, 0, negative 1, negative 1, negative 1. We're just going to have it black. The stone, so basic tile, is going to be very similar. It's going to be a byte ID of 1, so that's going to be the first tile, the second tile in this array here. It's going to be at x1, y0, and it's going to be at colors.get. We're just going to make this a generic gray color. I don't actually want to do anything special with it right now. We might actually put some content inside this tile later. That's why it's going to be different from this void tile. So we don't want to use the black color. We do want to use this dark color, so we're just going to say like a 333, just to give it a darker gray. We don't want to use this lighter gray for now, so we'll just say negative 1, and same with this other one. So there's those. Now the grass one, we're going to say new basic tile. This one's not going to use the dark color. Why didn't the negative sign not go there? Negative 1, negative 1. Oh, wait, those shouldn't be negative 1, sorry. Sorry about that, I was getting ahead of myself there. So this one's going to be a byte ID of 2. It's going to be at coordinate x2 and y0. And the colors, .get are going to be, we're not going to use black. The darker color is going to be like a 131 to give a kind of darky green. And we'll say 141 for a kind of lighter green. And negative 1 for this white, because we aren't going to use white. So now what this is going to do is it's going to populate this tile right here. So we'll go back into the level here, and when we generate the level, we have it populating grass, but we want to see some stone as well. So we're going to say if x plus y times, I don't know, %10 is equal to 0. Sorry, if that's less than 5, let's just do that. Less than 5, else, copy this down, and we'll say stone. Okay, so there's that. Now what we're going to do is we're going to go into the game, and we're going to remove this because we don't need it anymore. And we're going to say, we're going to make a new level here because we need a level. So we're going to go down a little bit right here, and we're going to say public level, level, level. So it's a class variable. Then we go down to here, and we're going to create it into our init method. Level equals new level. Make it 64 by 64 for now. Again, it might not work correctly moving sideways to sideways, but we are just, for now, we'll fix that next episode when we do some of the entity stuff, so that the actual player moving stuff isn't actually where the camera is. So that's what that's going to be for. So then we're going to go down to the tick function. Did I make a level.tick? I think I did. No, I didn't. Level does need a tick function, so public void tick. Just in case we want to do any light kind of things in the level. So then we'll go down here to our tick function. We're going to say level.tick. Then we'll go down here, and we will say level.render tiles screen x offset and y offset, which we will create now. X offset is equal to x offset is equal to screen.x offset just for now, and int y offset is equal to y offset screen y offset. We could actually make a actually let's do that. We're going to make couple values in here. So private x y, if the private int x equals 0 equals 0. This will actually fix that error. So instead of making the y offset go up, we're just going to put y here, x here, x here. And then here we're going to say the x minus the screen dot width divided by 2, and so that the player is in the center of the screen, and y minus screen dot height divided by 2. Same kind of thing. So this way we'll have an x coordinate that moves around in the screen and a y coordinate that moves around the screen. Next, what we want to see, because if we run this right now, it will work, but the tiles won't actually look like tiles. They'll look kind of strange, because we're going off the sprite sheet here. So let's fix that sprite sheet up. So we're just going to, right now I'm just going to move these things down here, just so that we can see them below, so we don't actually have to change a lot. So this is the void tile, so there's what we're going to do for the void tile. For the stone tile, same kind of thing for now. We're just going to do a dark gray. So there's that. We're also going to do a dark gray for the grass, but for the grass it's going to have some speckles of the lighter one, I don't know, like that for now. And then we will copy this over and get rid of this little scope here and save it. So if I do run this now, it should look a little different. Not too sure how the generation is going to look. Yeah, that generation does not look nice. Let's go to the level. What did I do? Generate. Instead of x plus y, let's do x times y. Just to give it a little fancier thing. That looks a little better. So now if we go left, you'll see that it doesn't start at 0. You will see, actually, I won't render out a sprite for it now, but you'll see we do start up here, and if I go X, it's not going to go for a little while, and then it'll start going because we moved out of that quadrant, and then we're going all the way down here, and we stop at a certain point. Now, I don't know if this point is actually 64 by 64, so let's verify that. Let's go into the game, and right here, we're going to make a for loop. Int x is equal to 0, x is less than level dot width, because we only want to make it on the width. x plus plus. I don't care about the height, because if the width's right, the height's most likely right. Color is equal to colors dot colors dot get -1, -1, -1, 0, 0, 0. Just to make it black. If x percent 10 is equal to, let's say 9, because that'll give us the last one in that 10 array. I think it should. Actually, yes. If x percent 10 is equal to 9, or is equal to 0, and x is not equal to 0, because we don't want to see the actual 0 value. We just want to see every 10. Then we'll say color is equal to colors dot get. Say -1, -1, -1. Let's just use a red color. And then we will say font dot render. Why is this doing this? Oh, because it says colors, not color. Font dot, what was it called? Render? Yeah, render. And here we will just say x percent 10, just to get a number between 0 and 10. Screen, the x offset is going to be 0 plus x times 8, because the characters are 8 pixels wide, and we want it to be at 0, and the y is going to be at 0, and the color is color. So that should render out some numbers on the screen for us. So let's check that out. And they should go up to 64. So we see 0 all the way to 10, and this is the 10 mark, and then it goes 1, 2, 3, 4, 5, 6, 7, 8, 9, and then another 10. So let's count these. We should see 6 of these, and then 4 extra. So we got 1, 2, 3, 4, 5, 6, and 3 extra. So this is actually 63. But we are starting at 0, so this is technically correct, because we do have a 0 value way back here. Right here. So we do have this 0 value, which adds an extra one here. So that is actually correct. So that's good. So that's what we're doing this episode. Next episode, I will move this kind of X and Y hacky stuff into the entity class, because we'll start the entities. So I'll do that next episode. Thanks for tuning in, and I hope you guys have a good day.